The parabola. We will be going over the basics of the parabola, how they look, a couple examples, and in future videos we'll discuss how we derive the equation of the parabola. We're just going to go with some basics here. We have a parabola which is determined by a given line and a given point. Now, without drawing any axes here, if we have a line, and we'll call this the directrix, it's just the line, and we're given a point, we'll call that the focus. These two items here, our point and our line, will determine all the points on this parabola. And what we're looking for is we're looking for points that are equidistant between the focus and the directrix. So for instance, I may pick a point right here, and I'm looking for the distance between the focus and that point, and then this point and the directrix. And I want these, although my sketch might not be exact here, I want these distances to be equal. And if they are, then this point, and I'm just going to call it some random or general point xy, lies on my parabola. Now, one of the easier points to find would be the point between the focus here and the directrix. And you want something that's equidistant or equal distance between the two, so I can choose the point right in the middle here. Now that point will also have a special name there, but that point here, if we take a distance here to the point from the focus and the distance from the point to the directrix, this distance will be equal. And this point here is called the vertex. If I made more points, I may make a point here, and there might be a point here, and one over here, and then one over here, and I connect all these points. This one might be a little off here, and I just connect them here. What I have is I have my parabola. And any point that is on this parabola here, all along here, forever here, if I took, for instance, this point right here, and I figured out the distance to the focus from the point and to the directrix straight down, this distance would be the same as this distance here. So again, the distance from the point to the line, which we call the directrix, is equal from the distance from the point to the focus. So this is what our general parabola would look like. Now, we could have one where the directrix or line is above the focus. So if I call this the focus, and this line is the directrix here, all of my points on the parabola, starting with the vertex, which is halfway between the directrix and the focus, and I'm just going to do a quick sketch here, you would see that the parabola would open away from the directrix. So as you can see here, the directrix is here, the parabola opens away from it. In this second example, the directrix is on top, and the parabola opens away from it. It will never cross the directrix. There's two more cases here, and we'll go to the next slide here. And in these two more cases is where we have a directrix which is vertical, and this is the directrix. We have a focus, which we'll call F, and in this case we have a vertex, and then we have our general look of a parabola there. So again, in this case the directrix is to the left of the focus, then the parabola opens to the right. And in our last case here, we have a directrix, I'm just going to call D. We have a focus called F. We have a vertex right in the middle, and this would open to the left. So these are just the basic views of a parabola. The parabola is determined by a line called the directrix and a point called the focus. In future videos, we'll go through how we can derive the equation of a parabola and other examples. Thank you.